Hey Linux lovers, have you sometimes wondered what the hell does this process do? With Linux you can find out, and we have two tools there, strace and GDB, which will help you find out what a process does. Strace will show all the syscall that a process issues towards the kernel, like open, read, write, get time of day, and many more. GDB will be able to show you on machine level language exactly what's going on and which command goes where. So strace is complex. I needed 13 years to get through it and to be able to use it productively. GDB is much more complex. Let's get into it. I have created a little program here, Hello World, and it loads 42 into a variable AI, and then it prints out Hello World 42. Let's test it. Let's compile it, run it. And it does exactly what it is supposed to do, write Hello World 42 into the console, no new line, exactly like we wanted. Okay, let's strace it. And you see what's happening, what your operating system is doing, and now you can find out if your operating system is maybe spying on you, if you want. The deciding line is this here. So it all starts here with a bit of memory mapping and opening and Linux loader and stuff like this. I haven't really looked at it, but you're welcome to, and now you know how to do it. But what it does is it issues one syscall, and that is write. It issues the syscall write 1 hello world 42, 14 hello world 42. What does that mean? Well, first of all, you need to know that when it writes hello world, this ends up exactly here. So the output of the program is mixed with the output of strace. To get rid of this, we need to know about standard error versus standard input versus standard output. In other words, I show you now the same command, but we redirect the error output to def null. That means we will not see the error output. Now we see that strace is writing to the error output because the output from strace is no longer there. But we can also redirect the standard output to def null, and then we will only see the output of strace. Looks like this. And now we have the right line, write 1, hello world 42, 14 equals 14. Well, what does that mean? As I said, write is a syscall, and how do we learn more about syscalls? With the command man2. So I enter man2 write, and I find out write requires 3 parameters. The file descriptor, a buffer where it hands over what is supposed to write, and a size count telling the operating system how many bytes to output. And it will also return something. It will return how many bytes it has successfully output. Okay, let's look at this again. It says write 1 is the file descriptor, standard output, the console here. Then it has the buffer what to write here, and it is filled with the string that is supposed to be output. And then it says from this buffer output the first 14 bytes. Okay, let's count them. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 11, 12, 13, 14. So this string here is exactly 14 bytes long, and this is what write gets as parameters. Write it to the console, write hello world 42, and use the first 14 characters of this. And the write syscall then returns 14, which means I have successfully output 14 characters. Cool, huh? So going on with this, I would like now to show you GDB. So how much different debugging with GDB is. Let's try it. So we use the GNU debugger, as it is called, a.out, and we say run, and then it outputs hello world, and everything is done. Not much help, all right? So what do? We set a breakpoint in the main routine, and then we type run. And now the program is running, but it has stopped at its breakpoint and allows us to inspect everything now. And we can do this with the command disassemble. And we see that we are here exactly at this point in memory where it does a subtraction of 10. It leads a bit far to explain everything what's happening here. I have done this in another video that I can link here. But the deciding thing is here that it calls the routine that does printf, which ultimately does the syscall write. Okay, now we can say step I for step instruction, which means that exactly this command here will be executed, and afterwards we will find ourselves at this address here, quite a long ending in 55. So I say step I, and again disassemble, and now the arrow, this here, points one instruction deeper than where it was before. Why do we need this GNU debugger at all? Because, as you have seen, I have written an unusual Hello World program. I have written a Hello World program where a variable gets set, the variable I, and it gets set to 42. And this does not require a syscall. And this will happen, and it will be totally invisible to strace, but it will be visible to GDB. So in this case, when strace does not yield any result and you need to drill deeper, go for GDB. Okay, however, there are more hints that I want to give you just top of mind regarding strace. Regarding strace, you can also attach strace to a running process. For example, let's say ps -a to list all processes, and we find quite a lot of processes like the Chrome browser, and then I say, okay, strace -p, and then one process ID of the Chrome browser, and then we can see could not attach to process. Okay, can happen. Let's take this one, 20. And we see that that it is resuming an interrupted read. And this for us, what does this mean for us? It does not mean we can do nothing. It means we have to follow the process. So not only this process shall be attached to, but also the processes that this process spawns out. So we say strace -ffp, like follow, and then we see a lot more output. And for each of these output, you can now call man to footex to learn what it does, man to epoll wait, man to restart syscall, and so on and so on. Another important thing about strace, in my opinion, is that you get a lot to read where you see 3 dots. This means here, for example, we have 832 bytes that are supposed to be written, or no, to be read in this case. So it is supposed to read 832 bytes from the file descriptor 3, which is obviously this here, which just got opened. So this file, libc.so.6, this is being opened, and it gets assigned the file descriptor 3, and then the program immediately reads from this file descriptor, and it tries to read 832 bytes, and it does this successfully. However, because strace is set as it's set, it does not confuse you by outputting so much data. So you are missing data, and if you do not like this, you can increase the width and the size of the output of strace. And I say it here, the size of the output should be 999. So after 999 bytes, it will be cut, which makes sense. But before this, all will be shown. And for example, here we have a read operation where it reads 784 bytes, and they are all shown here, from here to there. And here, before, I told you that we have 832 bytes that we are supposed to read, and now you can see them all. And from time to time, this is very helpful if you see what the program is actually reading from the network, from files, from the keyboard, from wherever. So I hope this little overview was useful. If yes, I'm happy. If no, give me feedback in the comments. I love discussing with you. See you over there. Thank you.